Okay, so today let's talk about self-attention. So let's talk about vectors in NLP, right? Why language must become vectors? Yeah. So computers fundamentally operate using numbers and mathematical operations. For example, a sentence like I love cricket means nothing to computer until it is converted into numbers. In machine learning, we convert words into vectors. A vector is simply a list of numbers. For example, when we say cricket, it gets converted into mathematical numbers like 21 or like 12 or 84, 48, something like this. Okay. Now, these numbers allow the model to perform operations like measuring the similarity, performing the matrix multiplication, learning the patterns, etc. etc. For example, think of a music recommendation system where songs are not stored as raw, sad, or fast. Instead, they are represented numerically. So, for example, song A, we go and check for the tempo, the sadness, and the energy in it. Similarly, for song B, we check the sadness, energy, the tempo, right? Now, the system sees they are close in vector space, so it recommends the similar song. NLP does the same with the words. If you have not watched my previous video, like the first video of how LLMs work, please go and watch it because I have explained there what vectors are, what closeness means, similarity means, etc. Now let's go to our second topic, that is one hot encoding, right? So the earliest approach was one hot encoding. It was like the first generation NLP. So suppose we have the vocabulary here: cat, mat, rat, and cat is represented as 1 comma 0 comma 0, mat is represented as 0 comma 1 comma 0, and rat is represented as 0 0 1, right? So every word here gets a unique index, right? How it works is, suppose the vocabulary size is n and the vector size is n, and if the vocabulary contains, let's say, 10,000 words, each words become like 0 comma 0 comma 0 comma 0 comma 0 comma 1 comma 0 comma 0 comma 0, so on. So the major problem we face here is, first, huge memory, right? If vocabulary is like of 1 million words, then the vector length will be 1 million, right? So almost all the values will be 0, which is like a very inefficient way to do this. Second is, will not have any meaningful information, right? Because what happens is, one hot vectors treat all the words as equally unrelated. So like, cat can't be related to dog, cat can't be related to airplane, like the distance will be same. So the distance of dog from cat will be same as distance of aeroplane from the cat. But we as humans know that a cat is closer to a dog than to a aeroplane, right? So what I'm trying to say is, one hot encoding cannot capture the semantic relationship. Again, if you don't know what a semantic relationship, please go back, watch the first video. It feels more like promotion. So this is the last time I'm doing it. Just watch the first video and please watch it sequentially. But if you know things, then yeah, sure, you can just directly watch it. Now, let's talk about a real world example. Yeah, imagine a dictionary index number system. So the cat's entry is suppose 2034, the dog's entry is 7811, plane's entry is 112, right? Numbers identify words but contain no meaning. Are you understanding? These numbers, right, whatever we have, these are useful for identifying words, but it itself contains no meaning, right? So let's go to our third topic, that is static word embedding. Static word embeddings is like second generation of NLP. So researchers developed word embeddings. The popular methods to do word embeddings were word to vector or glove. I'm sure you would have heard of word to vec, right? So instead of having a large sparse vectors, words become dense vectors. So like the king, the queen, the doctor, right? So they'll be more closely related. So the vector size typically is like between 100 to 300 numbers, right? Now, the key idea was, the meaning from the context was, embeddings are trained on large text corpora, right? For example, the king ruled the kingdom. Now, model learns that king is somewhere similar to queen, but king is not at all similar to banana, because the king and the queen, they appear in the similar context, right? Now, now think of map of cities, right? So cities with similar characteristics cluster together. For example, a similar cluster would be what? Paris, Rome, Madrid, etc. Another cluster can be formed as Apple, Microsoft, Google. So word embeddings create a map of language. Now let's talk about the average meaning problem, right? So static embedding give one vector per word, but many words have multiple meanings, right? For example, apple. Now apple can be a fruit or a tech company. I mean, at this point we both know like that apple is a tech company and a fruit, right? So when we are training our data, right? If 9,000 sentences used apple as fruit and 1,000 sentences used apple as company, the final embedding that will come out is apple is most probably a fruit, right? So when the model reads apple released a new phone, now this is crazy. It doesn't think of an iPhone or like the tech company. It thinks of fruit. It still thinks fruit. To give you a real life example, think about the word bank. Now, as I explained this in the last video, the possible meanings are river bank, financial bank. Now, if someone writes a sentence, I deposited money in the bank, and there's another sentence called the boat reached the river bank. Now, the static embedding is like the mixture of both the meanings, and this causes confusion, right? So let's talk about why static embeddings fail in translation. So as I explained earlier, let's take another example sentence. Apple launched a new phone while I was eating an orange. Now what static embedding does is maps apple with a fruit, maps orange with a fruit, but the context says is apple is a company and orange is a fruit. Because static embeddings cannot adapt to context, translation system may produce wrong outputs, right? This was a major limitation of the early NLP models. Now comes our superstar, self-attention. I don't know why I said it like that, but okay. Modern NLP uses like models such as self-attention. Again, this is the same model that was introduced in the paper. Attention is all you need, which led to the transformer architecture. Self-attention allows each word to look at other words in the sentence. For example, if I say example sentence, Apple launched a new phone. When processing Apple, the model checks Apple launched a phone and it realizes that the context is of company. But when we say I ate an apple, the attention focuses ate an apple, meaning it's a fruit. So the technical idea is again the same thing which I explained you earlier, which is the word generates three vector, query, key and value. Self attention computes attention score is equals to query times key, which determines which word matters the most, right? To give you a real life example, imagine a conversation in a meeting. The sentence is the CEO thanked the engineer because she solved the bug, right? Now, who is she? Your brain automatically checks the context. CEO, engineer, solved a bug. Most likely, she is an engineer. Now, of course, we know this because we are having day-to-day conversation with our people, and we have grown and we are like a grown adult. But think about a child, right? Or who is just learning to understand the language, who you are just teaching grammar because AI is in that phase right now. So it checks everything, right? So self-attention does this. Now, let's talk about contextual embeddings, which is like the modern sort of NLP. Not sort of, it is a modern NLP. So, like the modern models, they generate different vectors depending on the context. So, sentence one is, I ate an apple, right? What vector does is, apple is a fruit vector, right? Sentence two, Apple released a new iPhone. What vector does is, Apple is a tech company vector. Same word, different meaning, right? Now, system using these contextual embeddings, for example, are like BERT or GPT. These model basically revolutionized the translation, the chatbot, the search engines, the summarizations, right? Now, I don't even think for this I need to go into the real world example, but let's go with it. Google search, when we search query, when we say, hey Google, please find Apple stores near me, or hey Siri, please find Apple store near me. System understands company meaning, but query, when we say is like apple nutrition facts, the system understand the fruit meaning, right? Now, translation system, so for example, when I say apple launched a phone, and I want this in like Hindi translation, so एप्पल ने नए फ़ोन को लॉन्च किया, या इफ़ आई वांट दिस इन लाइक फ्रेंच ट्रांसलेशन, सो इट विल बी ला पॉम अ लांस ऑन टेलीफोन. My French is not that good. It was my fourth language. Excuse me if I made any mistake. Which means oh, fruit launched a phone. The third is like the voice assistant. Now, I just talked about like assistants like Siri or Google Assistant. They must interpret the context, right? So when I say play Apple Music, meaning the Apple services and not the fruit. So this is how NLP evolved, and this is how self attention came in the view. In other lectures, we'll discuss more about transformers. I hope you enjoyed it. Thank you.